a load is applied on soil, stress spreads downward and sideways through the ground, and we calculate it using the Boussinesq equation. We will also solve a gate previous year numerical on this. This concept is used in foundation design and settlement analysis and is one of the most important stress distribution topics for competitive exams. Suppose a concentrated load P acts on the soil surface. Now consider a point A somewhere inside the soil. The stress at that point depends mainly on depth Z and the radial distance R. As depth increases, stress decreases. As radial distance increases, stress decreases. These are the assumptions used in Boussinesq theory. Remember these for theory questions and MCQs. Now comes the main equation. Sigma z equal to 3p by 2 pi z square into 1 by 1 plus r by z square whole power 5 by 2. This gives the vertical stress at any point in a soil mass due to a surface load. When the point is directly below the load, r becomes 0. Then the equation becomes very simple. Sigma z equal to 3p by 2 pi z square. This formula is extremely important for numericals. If depth increases, stress decreases because z square is in the denominator. And if radial distance increases, stress again decreases. So maximum stress occurs directly below the load. Now let us solve a previous gate question. A load of 3000 kN is applied. Points P and Q are at 1 meter and 2 meter below the ground along the line of application of the load. We have to find the ratio of increase in vertical stress at P to that at Q due to the application of this vertical load. Let's visualize it. Notice carefully, both the points lie directly below the load. That means R equal to 0. Many students miss this observation. Since R equal to 0, sigma z equal to 3p by 2 pi z square. So stress is inversely proportional to z square. The ratio of vertical stress at P to that at Q is sigma P by sigma Q equal to zq square by zp square. That is equal to 2 square by 1 square equal to 4 is the answer. These are the most common mistakes students make in exams, especially forgetting the shortcut formula. If this video helped you, subscribe for more geotechnical engineering contents.